Okay, cool. Hey, everyone. I guess I will stand up for now. I am Greg from ENS, and today we're going to be talking about ENS as a source of identity in your apps. So first, let's start off with describing what is ENS. The Ethereum name service is a decentralized, permissionless naming protocol that lives on Ethereum and scales to the entire internet. That's our kind of fancy one-liner, but a more easier way to describe it is that ENS turns complex hex addresses into human-readable names. So you might be familiar going across different crypto apps, and you see an address like OX179A86, so on. This doesn't really mean anything to users. It's just a long, confusing, random set of numbers and letters. But ENS turns that address into gregscroll.eth, a very human-readable name that is easy to understand, easy to say, remember, and so on. Another way to describe this is that ENS is a user experience protocol. We exist to make Ethereum and the whole crypto ecosystem really just easier to use. You can imagine the difference of saying, hey, send me $5 to, again, this long address, OX179A, blah, blah, blah. Nobody's going to say that. Nobody's going to remember that or type it in their phone. The alternative is just saying, hey, send me 5 USDC to gregscroll.eth. Very easy, very comprehensible, and so on. This is kind of the idea of ENS being a username, right? You just go from a username to an address. But over time, ENS has really become more of a profile. So this is a look at my ENS profile. I do have the name and the addresses, but I also have an avatar image and a description and a link to my website and so on. An ENS profile really allows you to store any sort of data alongside your name. Maybe it's coming back. Okay, we're back. Cool. Yeah, so you might be familiar with this experience of you log into an application, you connect wallet, and it will just show you something like this in the top corner, right? A gray icon and the address as if that's supposed to identify you as a user. But this is kind of the same thing as getting an email from an intern that forgets to fill in the blank of like, hey, our customer's name that we definitely know and care about. It's like very not personal. It's not a good experience. And what ENS lets application developers do is when you connect a wallet, you can recognize the user by their name because ENS is your portable Web3 profile. It kind of comes with you across these different applications that gives you a better user experience. And so an example of 2 apps that use this, there are hundreds of apps that do this, but just 2 that came to mind are Snapshot and Matcha. When you sign into these apps, they will recognize you by your ENS name. And it just feels good. It is better for everyone. A way to think about this is that users of crypto-powered experiences should never have to interact with hex addresses. This is kind of a core belief of ENS. We really want to just remove hex addresses from the Ethereum user experience. And the way you do this is when you're building your app, just think, anywhere you read or write a hex address, you should be able to use an ENS name instead. So you might be transferring assets to somebody, or you might be reading a list of addresses from a block explorer. All of these cases, you should use ENS. Cool. So so far we covered what is ENS and maybe why it's important. Now let's just go over how it works. And I'm going to talk for a few minutes, and then we'll try and do a live demo so you can really feel it. ENS is powered by 2 core processes. There is forward resolution, which is the idea of going from a name to some sort of data, normally an address. This is the mapping that I've described so far. So for example, my address, the address of nick.eth is OXB8C and so on. There's also the opposite, reverse resolution. And this is what empowers the kind of portable profile thing that I described before. The combination of these 2 things is what we call a primary name. So when I sign into an app, the way the app is able to get my name from the address is because my address's primary name is gregscroll.eth. And then you can get all the other data from the name. What I described before of forward resolution and reverse resolution, these are just 2 examples of it. So forward resolution is the idea of you type in a name and it goes to an address. This is what you would use to transfer ETH to somebody or anything like that. And then the primary name can be looked up on something like a block explorer. And here's another way to really tangibly feel the difference of the 2 experiences using ENS and not. It's the matter of greg_scroll.eth sending something to a smart contract that is named, or me receiving something from Cameron and it goes to Greg. I can just look at this and very easily understand what's happening. Where the alternative is like some random address that means nothing to me and sending something to some random address that means nothing to me. This is like a meaningless way to read what is happening on chain, and this is much more clear and transparent, powered by ENS. The way we configure this reverse resolution, which again is what makes ENS this kind of portable profile, is via contracts that we call reverse registrars. Yeah, it'll come back. Okay, nice. Reverse registrars, prior to a month or two ago, were only available on L1, Ethereum mainnet, but now they're available on Ethereum mainnet and a bunch of L2s as well. And so what this means is that it is possible to have a fully end-to-end experience with ENS on an L2, which is very cool and exciting and I think relevant for what you guys are building at the hackathon. And so now I'm going to take some time to basically walk through what it might look like to build out an end-to-end experience. I'm going to try and do this with one hand. So let's see how this goes. Okay. I have a few things open here. Can you see that? Yes. The first is a tool called Durin, durin.dev, and I'll have QR codes for this in a little bit. But the idea is that this is a framework for deploying L2 subdomains on ENS. And a subdomain is like something that's under a name. Say I have name.eth, right? But as an application developer, I have name.eth, but I want all of my users to have a free and easy to register username under that. So it's like sub.name.eth is a subname. And these can be registered for free under an application, for example. And the way this works, I will refresh, is a step-by-step process that walks you through a few different things. So first, there's this idea of a registry. A registry is a smart contract that will store all of the names for you in a namespace. So like sub under sub.name.eth and sub2 and so on. So we're going to choose a name that I own in the connected wallet, right? I've already connected my wallet. And let's choose Bob, because all demos need a fun example name. And then let's choose a chain to deploy this registry to. I'm going to choose Base Apolia because I imagine a lot of you this weekend might want to be using Base Apolia. And here, let's deploy my registry on L2 Sepolia. Again, this is the contract that will store all of my subdomains. So imagine bob.eth is the name of your project, right? And then somebody will be able to come along and register greg.bob.eth, for example, as their portable Web3 username. And this is on L2. The next step that we need to do is change the resolver of bob.eth on L1. So this is on testnet, on Sepolia in this case. A resolver of a name is basically what's responsible for determining how a name's data is looked up, meaning in a resolver, I can store that my address is OX1234, or I can write a resolver that reads data from some other data source. In this case, Durin provides a resolver that looks up the data from the L2 itself. And so this step 2 is basically connecting your L1 name, bob.eth, to your newly deployed registry smart contract on L2. I've already done that here when I was prepping for the demo, but it's just a simple click of a button. From here, what we have to do is set the target registry address. And so we'll wait for a second as this comes back. OK, nice. And what we've done so far is first we have bob.eth, right? And then we deploy basically the contract that will store all the data for the subdomains under bob.eth. In the second step, we are connecting that new contract on L2 to bob.eth on L1. And then we go ahead and create a contract that allows people to actually create the subdomains. This is where you would go into the actual code. I already have this cloned to my computer, and so I will switch to it now. Not that, but this. Cool. And this is the code for Durin, which is available right here at this open source link. And once you're here, it says customize and deploy your L2 registrar. The L2 registrar is a contract like this. And it looks maybe more complex than it is just because of all the comments. I'm going to try and make it bigger for you. Cool. But there is only one function in here that actually matters, and that is this register function. This register function will create a subnode, which is a subdomain, in the registry that you already deployed from Durin. Some of you are struggling to see. Let me try and put it on the right side. Here. Maybe I could split the screen. OK, maybe that's easier. Or maybe that's worse. We'll roll with it. This L2 registrar will create subdomains in the registry contract that we already deployed from Durin. And the only thing that we need to do to enable that is connect this L2 registrar contract with our registry, which is already deployed. And I know these names are kind of confusing, so I'll make sure to leave time at the end for questions. But what we want to do here is first customize this contract. An example of a customization would be adding a price to register a name, or requiring that the user submit some proof to register the name. Say, for example, as part of your experience, the user has to mint an NFT, and in order to get a name, you check that they own an NFT, or you check that they are paying for this name. When we say customize the L2 registry, these are the type of things that we really mean. And so Cursor wants to charge for a name. So let's just let it do that, I guess. OK, we're going to require that the user pay something. And then we'll create subname. So this is an example of a customization that you would do when you're deploying Durin. And now we can deploy that. So the way we deploy this is I'm going to open up the README. And this walks you through everything as well. So here, sorry, one sec. OK, cool. That's OK. At this point in the README, we have done all of these things. We've deployed the registry, we've enabled name resolution, and we've customized the registrar template. Now we want to deploy the L2 registrar contract. The way we do this is we create an env file, and we have to paste this registry address into this L2 registry address environment variable. And the reason we need to do this is because the contract we deploy has to be connected to that original registry that we deployed in Durin up here. And once we've done that, we can go ahead and deploy our contract, which is this one that I just customized to add a fee to. So I'm just going to paste this command that it says to paste. And this should be deployed in a second. It should be this. Cool. This is our new contract, the L2 registrar. And the L2 registrar is what users are going to actually interact with in order to register a name in the underlying registry. But in order to connect those two things, what do we have to do? We have to connect L2 registrar to L2 registry. And we do that by calling add registrar on the registry. So let's go back to the registry, which is this, that we deployed a minute ago from the Durin website. And you will see that there is a method called add registrar. I'm going to connect my wallet, and I'm going to add my newly deployed contract, which is this one. OK. This is basically approving my registrar to be able to create subnames in my registry. Again, this is the registrar, and this is the registry. And the outcome of all of this is that now any user can call your contract, the registrar contract, to register a name under bob.eth. And so let me show you the before and after here. I'm going to open the ENS app on Sepolia for test.bob.eth, just to show you that right now it's not working. Right? There is no data associated with this name. There's no address. And once I register this test name, right, I will set the owner to myself. And in the contract, the customization that we did was requiring that the message.value is over 0, right? So if I press 0, then I should get an error. I would expect this to fail. Let's see. Yeah, that failed. But if I send some amount of value, then this should succeed. Great, no error. And the outcome of this...
Because that was the requirement for the function that you validate if the user has to know the value.
Yes.
But you can put other kind of things. For example, you can put a zero knowledge proof validation or something.
Exactly. So the question was, why did the second transaction succeed when the first one failed? And yes, the answer is because of this line that we just added. As that's an example of something that we would want you to customize in the Durin contract, but it can totally be free. It doesn't have to be a paid fee. An example of something else that you could do is like a zero knowledge proof that proves, somehow you've been approved to create a name. And so you can add a parameter to this register function that's like, bytes, memory, data. Sure. I'm going with one hand and cursor, so this is a little bit difficult. But and then here it's like prove the message. What does cursor want to do? Great. And then you could deploy that sort of thing as your contract. I'll expand it a little bit. And then the user would only be able to create a name if they meet those requirements. So the idea here is like, we provide an example that is free and open for anybody to create subdomains, but really encourage you to think about how it fits best into your app, whether it's a fee or as your knowledge proof or something like that.
Like Instagram variant, like Lens, that you have subdomains for all the usernames in the application.
Exactly, yeah. Subdomains for kind of any sort of username in your application. And so the end result of that latest transaction that we did is test.bob.eth now suddenly has an address. And thanks to the network effects of ENS, you can go into MetaMask or Rainbow or any of these things, any of these applications that already support ENS, and suddenly you can send assets to test.bob.eth. And this is kind of the magic of ENS. But this is just the first part, right? So test.bob.eth is basically our username, right? It is not the profile yet because we haven't set up that reverse resolution, if you remember the difference. So in order to do that, I have a very basic front-end kind of demo to walk you through. Let's see. I will also make this bigger. And I will make this smaller. Okay, nice. Let's see if this works. So test.bob.eth works as a username. It points to the address OX179A and so on. But in order to configure the reverse and make it a user's primary name on base, we have to use the reverse registrars. Remember, I mentioned this in the slide earlier. The way we do that, we're just going to do it manually, is we find the address of the reverse registrar on the relevant chain. So because we are using base Sepolia in this demo, wait a second, but there's an address for base Sepolia on this docs page, and now I can see. Cool. This is the contract on base Sepolia for the reverse registrar. Again, the reverse registrar is how you configure the primary name or the reverse record of a name. And so what we're going to do is go to this little front end here and set the reverse record for my address. And my address is the address that test.bob.eth resolves to. Right, so I'm going to say that my reverse record on base should be test.bob.eth. And you'll notice this is very similar to that little profile example I had in the slides. This is what it looks like when you sign into an app that doesn't support ENS, or if you don't have an ENS name. It's a bad experience. But if I set my primary name up to be test.bob.eth, which we are going to do right now, then it should update, I think. Let's see. There we go. And now when you sign into any application that supports ENS, they look up your primary name on base, and it will be test.bob.eth. And just going a step further here, now we kind of have this portable profile because any application that I log into will show test.bob.eth. But we want to have an avatar, right? The avatar right now is still a gray circle. And so an example of how we set that avatar is using ENS text records. Text records are just arbitrary data stored attached to an ENS name. And the way we configure that is in the registry contract that we already have deployed, right? In this registry contract, and I know we only have a couple minutes left, so I'm going to speed through this and then leave a few minutes for questions. You will see a setText function. SetText is the function that you need to set a text record for an ENS name, and it takes 3 arguments that you probably can't see. It takes a node, a key, and a value. The way we get the node in ENS is through this function called a name hash. Name hash is easy to get in VM, for example. VM has a function that is just name hash. It's built right in. Or we have a helper in this contract directly that is make node. Cool. And the way you make a node is you give it the parent node and the label. So the parent node in this case is right here under base node. And that is the name hash of bob.eth. And so we want to get the node of test.bob.eth, which is this. So we have this, and then we are going to set the text record of that node to be the key is avatar, and the value, I'm just going to grab the image address of my profile picture for my website, and here we go. Now, test.bob.eth will have an avatar image that appears anywhere that supports primary name lookup. So for example, now we're back on the ENS Manager app. Even though I didn't do any transaction on this, it just recognizes the avatar of my name. And if I go back to my front end and I refresh this, then now my portable Web3 profile suddenly has a username, an avatar, and so on. And so the idea is that any application I sign into with this wallet would now be able to load this portable Web3 profile, which I created on base. I set the primary name for it on base. I didn't have to touch L1 Ethereum at all. And from a user side, it would be a very seamless experience by just having a username here and kind of set the primary name for them. I know today I was hopping around a few different things, but you can imagine how building all these interactions into a front end would make for a more seamless experience. So that is most of, I think I had a couple slides, and then I will accept questions. The summary here is basically anywhere your app shows a hex address, it should instead show ENS names. When you're building your app and you notice hex addresses in your front end, just think about how could this instead be a name, because we believe that that creates a better user experience. The website for Durin is durin.dev, D-U-R-I-N. The QR code is here, which I will leave up for a few seconds. The overview of primary names is available here on our docs, which I will also leave up for a few seconds. Our prizes this weekend are best use of ENS, first and second place, and then a pool prize for anybody that integrates ENS at all. And so if you build on ENS, there's a very good chance that you will at least be able to win something, and we are happy to help you do that throughout the weekend. These are the 2 last QR codes for a starter guide that has links to all these other things that I've shared, and my Telegram if you want to reach out directly. We will also obviously be here all weekend until at least midnight tonight, and then probably like 2 or 3 a.m. tomorrow, because we like to support hackers throughout the night. But yeah, I will leave it on this and save a minute for questions. But thank you guys for listening. Yeah, let's take one in the back.
Because Polkadot is on the EVM, I could use ENS to put Polkadot address.
Yes, you can use the Durin contracts on Polkadot and create subdomains. So for example, your project.eth would always be on L1, but your registry contract and your registrar contract that I showed could be on Polkadot. And so this allows kind of a seamless experience, even if your app is not on, Ethereum L1. But sweet, I think that's all we have time for. So thanks again, and come by the booth if you have any other questions.